All right, good day. Hope that you're doing well. Now, in this video, we're going to be looking into trigonometry questions, right? Now, these questions are from a previous exam questions. So we're going to be dealing with 2D trig, right? We're going to be using shapes and making use of those shapes. We're going to try and answer the following questions relating to trig, as well as we're going to be solving identities, right? Now, for the first question, they say, in which quadrant does the terminal arm of angle 182 lie? Now, let me just try and illustrate that here. If I were to draw my 2 or my Cartesian plane here, right? Now, this is my Cartesian plane. This is where it starts. This is 0. And by the way, this is quadrant 1. This is quadrant 2, 3. This is 4. Now, as a result, that would be my starting point. This is 0. And to move from here to here, it will be 90, 180 degrees, 270, and 360. Now, I want you to note something. Now, this quadrant here, it will be values between, on the first quadrant, it will be the angles between the terminal arm, which has the angles between 0 and 90. Quadrant 2, it is between, right, this here is between 90 and 180. And quadrant 3 is between 180 and 270. And if you note here, it's 180 plus, right? Now, as a result, this angle, it would lie in this quadrant, which is quadrant 3, right? Because of this quadrant is between 180 and 270. So here, it will be quadrant number 3. Now here we need to roughly illustrate angle 45 degrees on the Cartesian plane. So now if I were to roughly illustrate that, remember I said this from this point to that point it's 90, meaning that 945, it has to be half of that, right? So here I'm going to try and draw it here, and my reference angle should be here, the 45 degrees. Now, this is the shape that we're given here in this question. We are given this big triangle, which is DCE, right? And we also have this right angle triangle, which is DHC, as well as DHE. Now here they want us to give three answers for the ratio tan of A. Now first question for this type of questions, try to separate step one, separate your triangles, the triangles that you have. So I'm going to draw them on the side, each of them. So starting off with the big one, right? So I'm going to try and draw it here. Right, and remember here it's 90, and this is my point D, this is my point C, this is my point E. Now, in terms of alphabets inside our big circle, so angle C is B, angle E is A. Now, remember here we're looking for tan of A, right? A is our reference angle, so this would be my reference angle. So this is the first triangle, the big one. Now, let me draw the other triangles that I have. Now, here, as you could see, I have a right angle triangle, right? So remember, if this side is equals to 90, this side is also going to be equals to 90 because sum of angles on a straight line should be equals to 180. So as a result, I have two right angle triangles. So the first one, I'm going to draw the small one. So, right, and this would be my right angle. This would be my D. This would be my C. This would be my H. And remember, I'm only interested on the reference angle, which is my A. So this would be my reference angle. Now drawing the last triangle. Now remember here it's 90 degrees. This is my point D. This is my point H. This is my point E. And my reference angle A, which is here. Now that I've separated my triangles, remember I need to give them three ratios, right, for tan of A. Now let me do that on the first triangle. Now remember your SOHCAHTOA. Sine is opposite over hypotenuse. Cos is adjacent over hypotenuse. Tan is opposite over adjacent. Now, if I were to draw a right angle triangle here, for example, let's say this is our right angle triangle. I want you to note something. And this is theta, our reference angle, right? Now, when I say opposite, I'm going to look for the angle that is opposite to this theta. This would be my opposite, right? And if this is 90, remember, the line that is opposite to your 90 degrees would be your hypotenuse. And as a result, this line is adjacent to this reference angle. All right, this is how you go about determining these values. And tan here, as I've said, it's going to be your opposite over your adjacent. So we need to do so for these three triangles we're given. So now, what is the angle, or what is the line opposite to our angle in this case? right? This is our line which is opposite. Okay, let me change the color of my marker. Now, this line here, it's opposite. And because this line here, it's opposite to my 90 degrees, this would be my hypotenuse, meaning that this here would be my adjacent. And remember, I'm looking for tan of A, which would be my opposite in terms of alphabets DC, over my adjacent, which is DE. This would be my first answer. Now I need to do this for all these triangles. So now this line here, CH, because it's opposite to angle A, this is going to be my opposite. And this line DC, because it's opposite to 90 degrees, is going to be my hypotenuse. As a result, this here would be my adjacent. Now remember, I'm interested on tan A. Now, which is my opposite, which in this case is CH, divided by my adjacent, which is DH. Now for the other triangle, DH is opposite to angle A, so this is going to be opposite. Now DE, because it's opposite to 90 degrees, is going to be my hypotenuse. Now, as a result, this is going to be my adjacent. Now to find tan of A here, this would be equals to my opposite, which is DH, divided by my adjacent, in this case, which is HE. Right, and that would be my last answer. Now, proceeding to the next question. What is the height of your kite if it is flown at an angle of 52 degrees on a 15-meter long string? Now, as you could see here, this is the right angle triangle, right? And remember, what is your height? Your height, it is that line from your lowest point up until your highest point, right? And every time in your right angle triangle, this line right over here, it will be your height from your lowest point to your highest point. Now here they want us to determine the height, right? Which is the distance from our lowest point to our highest point highlighted in these dotted lines right here. Let me just do that here. So now, how would I go about doing that? So remember, I'm given a reference angle here as 52 degrees, right? Now I need to determine my height. Now I'm also told that this string here is 15 meters long, right? 15 meters. So now this is my right angle triangle. What is it that I have? Remember, what is this line that is opposite to 90 degrees? This is my hypotenuse. And what is it that I'm looking for here, which is my height? My height is opposite my angle, right? So this line is my opposite. Now, which trig identity can I use that has hypotenuse as well as opposite? Remember, you saw Katoa, it will be sine. Our sine is equals to opposite over hypotenuse. Now, in this case, I'm going to say sine of my reference angle, which is 52. This is equals to my opposite, which is what I'm looking for, the height, divided by my hypotenuse, which I'm given as 15. And I'm going to solve for my value of h. Now, how would I go about doing that? Now, I need to get rid of this 15, right? And because of its dividing, I'm going to do the opposite of what it does. So I'm going to multiply both sides by 15 so that these two could cancel out one another. Now, as a result, my h would be equals to 15 multiplied to sine of 52, right? Now, punching that into my calculator, the height would be equals to 14,8 meters. Now, on the next question, they say calculate the angle of elevation theta of the plane if it is at a height of 600 meters. Now, remember your height, it is this line from your lowest point to your highest point. Now, what is my height? My height is 600 meters. Okay, let me just write with the visible marker there. My height is 600 meters. Now, when it covered a horizontal distance of 800 meters. Now, horizontal distance, it will be 800. Right? Now, I need to calculate the angle of elevation, which is this angle right over here. All right. So now, what is it that I have that I can use? Okay, let me try and draw the right angle triangle right over here. Right. So let me just try and draw it here. This is 90, okay, this is not up to scale, but then I've tried. So this is 600 meters, this is 800 meters, the horizontal distance it covered. And then as a result, they're asking me to calculate this angle of elevation, which is your reference angle. Now, how can I go about doing that? So now let me first identify these values that I have. So because this 600 is opposite to this, that is going to be my opposite side. And remember, the line opposite to your 90 degrees is going to be your hypotenuse. So as a result, this would be my adjacent. Now I have my opposite, I have my adjacent. which trig identity can I use here, right? Remember your SOHCAHTOA, right? Tan, it's opposite over adjacent. So we're going to make use of tan. So tan of our reference angle in this case is going to be equals to, it's going to be equals to my opposite, which is 600, divided by my adjacent, which is 800. So as a result, to find this reference angle, I can just take the tan to the other side, right? So this would be theta, it's equals to the inverse of tan. You're going to press shift tan to get this, and 600 over 800. Now, when you punch this into your calculator, you're going to get your angle of elevation, which is what you were looking for. Now, if I punch this to my calculator, I'm going to get 36,87, rounding off to 2 decimal places. Now, for the next questions, which involve calculations. Now, here they're telling us that if 10 theta is equals to 8 over 15, and they give us a restriction. Basically, here they're giving us a clue where would our angle arm be, right? So if this is 0 to 90, remember, if I were to draw my Cartesian plane here, 0 to 90, it's in this quadrant, the first quadrant, right? Meaning that here, my arm would be in this quadrant, all right? Now, this would be my reference angle theta. Now, they're telling me that, all right, I need to determine the value of 3 sine theta, all right? So let me write it here. I need to find 3 sine theta multiplied to sine theta plus my cos theta. Now, what will be your first step? Step 1, you need to draw your right angle triangle. Draw your right angle triangle on a Cartesian plane. And you need to make sure that this right angle triangle that you're going to draw on your Cartesian plane, you're going to draw it in the correct quadrant, right? Make sure that your right angle triangle is in the correct quadrant. Taking into consideration the restriction that they gave you, right? They would always give you a restriction. Just make sure that based on this restriction, you're going to make sure that your right angle triangle is in the right quadrant, right? So let me just finish off drawing this. All right, now this would be 90. Now remember, I'm going to write my SOHCAHTOA here. TOA. Now remember, if they gave me tan, what is tan? Tan is opposite over adjacent. Now in this case, this line which is opposite to my angle, right? This is going to be my opposite because this line is opposite to my angle. And because this other line here is going to be my hypotenuse as a result of it being opposite to my 90 degrees. And here, this would be my adjacent. Now, what values am I given? Now, they give me, if remember, tan is opposite over adjacent. Now, my opposite in this case is going to be 8. My adjacent is going to be 15. Now, I need to determine my hypotenuse, right? And how would I go about doing that? So every time, whenever you're trying to determine a side on a right angle triangle, and you are given 2 sides, right? And you're trying to determine the third side, you need to make use of your theorem of Pythagoras, right? Remember the theorem of Pythagoras. I'm just going to do the calculations here. I'll just erase after, or let me do them here. So it's r squared is equals to x squared plus y squared. Now, what is your r? Your r is your hypotenuse. This is what I'm looking for. So I'm going to say r squared is equals to my x squared is, remember, this is on my x-axis. This is going to be 15 squared plus my y squared, which is going to be 8 squared. And remember, I'm looking for r, not r squared. So I need to square both sides to get rid of this square root. Now, as a result, my r to be equals to the square root of 15 squared plus 8 squared. Now, if I punch that to my calculator, my r should be equals to 17. So my hypotenuse here is 17. Now, after you've drawn your right angle triangle on your Cartesian plane, step 2, which is what we did now, determine or calculate all the sides of your right angle triangle, And remember, if you have in a right angle triangle, if you're given 2 sides and you are required to determine the other side, you're always going to make use of your theorem of Pythagoras, right? Just like we did in this case. All right. Now, last step. Now, step 3, now that you determine all sides, you can then solve your question making use of, right, using the right angle triangle with values that you drawn using your right angle triangle. Now, let us go about doing that. So here, This is 3 multiplied to sine theta. So I'm going to say 3 multiplied to, what would be sine here? Remember, sine is opposite over hypotenuse. Now my opposite is 8, my hypotenuse is 17, right? And remember, I need to solve this without the use of a calculator. Plus, what would be my cos here? So my cos is adjacent, which is 15, over my hypotenuse, which is 17. Now, as a result, I need to simplify this. And doing so, here I'm going to multiply numerator by numerator, denominator by denominator. This is the same as divided by 1. So 8 multiplied to 3, this is the same as 24. So 24 over 17 plus 15 over 17. Now, as you can see here, my denominator is the same, so I'm going to retain it, and I'm going to add my numerators, right? So I'm going to add 24 and 15, and my final answer should be equals to 39 over 17. Now, make sure you do not simplify this, because they said you must try to solve this without the use of a calculator. So this, it would be your final answer. Now, 3.3, we are given this expression, and they give us the value of x as well as y, right? And now, if we were to calculate this, we're just going to substitute x and y. So here's 2, 10 of my x in this case, it's 104, comma 2, plus 4 cos y. My y is given as 241, comma 7. Now, everything needs to be divided by 7, right? And if I do so, when I punch this into my calculator, my final answer should be equals to negative 1,40, rounded it off. Now, first, let us identify what kind of question is question B, right? So let me try and make my workings here. Now, question B is a general solution questions. And always, to answer your general solution question, you would need to make reference to your cast diagram as a reference. Now, let me just draw my cast diagram here. Right? So this is CAST. So this is cos. Here, all is positive sine. This is tan. Now, my angles, here it's 90 minus x. This side it's 180 minus x. Here it's 180 plus x. And this here is 360 minus x. Now, let us try and answer this question right over here, right, that we're given. So now, given that tan of A is equals to that, so first I need to find my A. Now they're telling me that my angle A should be between 180 and 360. Now remember, on my cast diagram right over here, remember here's 0, here's 90, here's 180. 180 starts here, this is 270, this would be my 360, meaning that it should be between my third quadrant or my fourth quadrant. It should be in one of these two quadrants, right? Because this is the region they gave me. My A needs to be between 180 and 360. Now, let me calculate my A. Now, so here, I'm going to solve for my value of A, right? So 10A, this is equals to, so I'm going to punch everything that side into my calculator, or I could leave it as it is, right? Let me just leave it as it is because it will give me a decimal when I do so. Because remember, you only round off when you get to your final answer. Now, if I want to solve for my value of A, I can simply take the 10 to the other side. So here I would be left with A. This would be equals to the inverse of 10. And in my brackets, I'm going to put 2 sine 35. Right? Make sure you put it in this way. Now, punching that into my calculator, so the inverse of 10, 2 sine 35, my value of A would be equals to 48,92, rounding off to 2 decimal places. Now, it's 48,92 within this range we are given? No, right? Meaning that we need to adjust it so that it could be in this range. Now, remember, this A, it was attached to your tan, right? And because it was attached to your tan, to adjust this, we're going to use 180 plus, which is in the tan quadrant. So here, this is our reference angle. And now, to find our final answer, A, it will be equals to 180 plus our reference angle, because here is 180 plus, and our reference angle here is 48,92. Remember, this is your reference angle. And as a result, my tan would be equals to, so rounding off, it would be equals to 228,92. Right? Now let's see if it's within, as you could see now, it's within this range we are given, right? And this would be your final answer. And lastly, you need to write down your period, right? So the period for our time graph is 180. So here you would say K 180, right, to represent the period of your time, and K is all values of that are real numbers, right? K are all values which are real numbers. Now, moving on to the last question we are given here. So here's the same question as the other, whereby we are given A, and now we need to find the value of this expression. Simply gonna do that by substituting our value of A. So this is cos of A, and our A is 200, and so let me write here so that I could see it with 229,8 plus 2 multiplied 2 times of 229,8 divided by 2. Now, before you can punch this into your calculator, first try to find the value of that and find the value of that separately. And then you can just find your final answer and you round it off, right? So first I'm going to punch it to my calculator, cos of 229,8, right? Which is equals to negative 0,645. So there are many values. Make sure you write all of them. Plus 2 multiplied to 10, 229,8 divided by 2. So punching that into my calculator. Also here, I would get a negative. I'm going to put it in brackets. Make sure you write all those values. And now I can just punch this in to my calculator to find my final answer, which I would round off to 2 decimal places. So now, of course, 229,8 plus 2 multiplied to 10, 229,8 divided by 2. And as a result, my final answer is going to be negative 4, rounding off to 2 decimal places, 95. Right? This would be the value of the expression. And that will be all for this question. Now, in the next video, we're going to be focusing on Euclidean geometry.